here we go. Step 1, make sure this is written in standard form, which it is. Write down your lead coefficient, which is 1. Write down your constant term, which is -3. Write out all the factors of 1. Well, 1 times 1. And of course we don't need doubles, so just 1. All the factors of negative, well, you're welcome to put the negative, that's my fault. It really doesn't matter because if you'll remember from your notes, we're going to put plus minus anyways with all of our numbers, so it really doesn't matter. The factors of 3 would be 1 times 3, 1 and 3. Okay, here we go. You take all of these numbers and put them on top of this number here. So 1 over 1 is 1. 3 over 1 is 3. Put plus minus in front of each one and you're finished. So we have 4 possible rational zeros. +1, -1, +3, -3. Now, I'm going to show you how they write their answers. I do not want you to write your answers this way, okay? To me, that's not very practical. The idea is to be able to look at your list and know what your zeros are, okay? Here they've got them all bunched together all over 1. I think that's confusing, so it's the same thing. This is the same as this, but I like this a lot more. Number 8. Alright, here we go. Step 1. Make sure it's written in standard form, and it is. Next step, write down your lead coefficient and your constant term. We're not worried about the signs. List out all the factors of 2. Well, that would be 1 and 2. All the factors of 10. Well, 1 times 10 and 2 times 5. Now you take each one of these numbers and put them over these numbers over here. So 1 over 1 and 1 over 2. Check off your 1. Now 10 over 1. 10 over 2. 10 over 2 is 5. 10 over 2 is the same thing as 5. Check off your 10. 2 over 1 is 2. And 2 over 2 is 1. Check off your 2. 5 over 1 is 5. 5 over 2 is 5 halves. Now you can erase any repeats. I see the number 1 is used twice. Let's get rid of that. Let's see, 1 half, 10. 5's used twice, so we'll get rid of 5. And I think that's it for the repeats. So we'll grab this and slide it over here. And we're done as soon as we do this. Oops, what happened? Let's see here. Did we lose it? Alright. Alright, here we go. Yeah, okay. Put it over here. Okay, we're done as soon as we go like this. Plus minus in front of each number. So we have how many possible rational zeros? Well, each one of these is 2 numbers, positive, negative, positive, negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 numbers. All of them are possible rational zeros for this polynomial function right here. Alright, check this real quick. Exact same thing we have, guys. Exact same thing. Alright. And moving on. And by the way, before I move on, another reason I don't like your answer being written like this is, look, you have 1 over 1 here, and you have 2 over 2 here. So you've got your doubles in here also. So I really want your answer to be written like this. It's very practical. You can put a comma between each one if you want to. You don't have to. It's up to you. But there's the list of possible rational zeros. Number 9. Step 1, make sure this is written in standard form, which it is. Step 2, write down your lead coefficient. Write down your constant term. Write out all the factors of this number here. Well, that's 1 and 2. Write out all the factors of 16. Well, that's 1 times 16. 2 times 8. And 4 times 4. Now, of course, you do not want double numbers here, so we do not need both of these 4's right here, so we'll get rid of the last one. Okay, here we go. Put each one of these numbers on top of these numbers. over 2 and got 1/2. I did that with all of these numbers. And then lastly, put your plus minus or your positive negative in front of each number. And there we go. Those are all let me put it this way, any rational zeros that exist in this function right here will be in this list somewhere. If there's any rational zeros for this function, they will be in this list. Alright, number 10. Alright, step 1. Make sure it's written in standard form, and it is. Next. Step 2, write down your lead coefficient and your constant term. Don't worry about the signs, it's not important. And then lastly, or not lastly, but next, write down the factors of each number. Well, 1 times 3 for 3. Over here we have a lot. 1 times 24. 2 times 12. 3 times 8. 4 times 6. And then it starts to repeat itself. 6 times 4. 8 times 3. So we're done. Those are all of the integer factors of 24. So now, take your first number, put 1 over 1, and put 1 over 3. 1 over 1 is 1. 1 over 3 is 1/3. Now take your 2. 2 over 1 and 2 over 3. 2 over 1 is 2, and 2 over 3 is 2/3. Now take your 4. 4 over 1 and 4 over 3. 4 over 1 is 4, and 4 over 3 is 4/3. Now move on to your 2. 2 over 1 and 2 over 3. Actually, do we have the 2 in here for twice? Let's see. Oh, my fault, guys. Big mistake. Sorry about that. Let's go all the way back here to the 1. Okay, 1 over 1 and 1 over 3. And then I went to 2 and 4. That's 24. Sorry, students. 24. 24 over 1 and 24 over 3. 24 over 1 is 24. 24 over 3 is 8. Okay, we're done with 24. Okay, students, I had to pause that. I'm not sure what I said last, but we're done with 24. Now we're going to take 2. 2 over 1 and 2 over 3. 2 over 1 is 2, and 2 over 3 is 2/3. Now 12. 12 over 1 and 12 over 3. 12 over 1 is 12. 12 over 3 is 4. Now moving on to 3. 3 over 1 and 3 over 3. 3 over 1 is 3. And 3 over 3 is 1. We have 1 already. Now we have 8 over 1. We already have 8. And 8 over 3, which is 8/3. Now we have 4 over 1, which we have that already. And then 4 over 3, which is 4/3. Then we have 6. 6 over 1, which is 6. And then 6 over 3, which is 2. We already have a 2 right here. Now guys, if I've made a mistake and there's any doubles in here, I would not take off on a test or a quiz. If you accidentally had a double, what I would take off is if you did not have, if you had some numbers missing that should have been in this list. Okay, so there we go. There are your possible rational zeros. Any rational zeros that exist in this function will be in this list somewhere. Okay, alright, moving on. Numbers 11 through 19, we're going to find all of the rational zeros. Rational zeros, so here we go. First thing you do is you put you put 0 in for g of x. And then we're going to break this thing down and find the zeros, okay? So here we go. The first thing you always want to try to do is factor. That's the fastest way to solve these. Okay, let's try to factor. This is a 4-term quadnomial. This is a quadnomial. We know what to do. We pull out what's common in the first two, which is x squared. And pull out what's common here, which is nothing. So I'm going to pull out a 1 because this is negative. I'll make it a negative 1. And this is x plus 2. I'm not going to get x plus 2 over here, guys. I'm going to get something like 11x plus 12. Okay. Does this parentheses here match this parentheses here? No. So I cannot factor this the way I've taught you to factor it, okay? So here we go. Here's what we're going to do. We're going to have to list out the possible rational zeros and then test them, okay? So here we go. Lead coefficient is 1. Constant term is 12. Factors of 1 would be 1. Factors of 12 would be 1. times 6, 3 times 4. Okay, now, think about it, guys. We can do this really fast. We're putting each one of these numbers over 1. Well, anything over 1 is just itself, so we have plus minus 1, plus minus 12, positive negative 2, positive negative 6, positive negative 3, positive negative 4. Alright, there we go. So, there's my possible rational zeros. Now, I have to start checking these to find my zeros. So here we go. I'm going to start with my lowest numbers, work my way up to my highest numbers, okay? I'm going to start off with positive 1. So I'll put a positive 1 here. I'm going to use synthetic division to see if I get a 0 out over here, alright? So I'll put a 1, then a 2, then a negative 11, then a negative 12. I should have a 3 here. Add 1 is 4. I should have 4 numbers, and I do. So here we go. 1, multiply, combine, 1 times 3, combine, 1 times negative 8. I'm not getting 0 here, am I? Not at all. So let's try another number. Obviously, positive 1 didn't work. Let's try negative 1, okay? Let's see what happens. Bring down your 1. Negative 1 times 1. Combine. Negative 1 times 1. Combine. Negative 1 times negative 12. Positive 12. Booyah, look at that. 0. Okay? So, now I know one of my zeros is negative 1. Negative 1 gave me out a 0. Okay? So, now that I've broken this down, I have taken this third degree polynomial and I've broken it down now to a second degree. X squared, x, and that's my constant term. So I have 1x squared, positive x, negative 12. Now, I've got to find the zeros for this. But remember, you might be able to factor it. If you can factor it, you can find the zeros a lot faster, okay? So here we go, let's factor it. I have a trinomial with a lead coefficient of 1. Got it? So, what two numbers will multiply together give me negative 12 when they give me positive 1? Well, I'm thinking of these two numbers. If I multiply those two numbers, I get negative 12. If I combine them, I get a positive 1. So the factorization is x plus 4, x negative 3. Now take each group. Remember, this should be set equal to what? 0. That's what we're doing, guys. We're finding zeros. So if you factor it, set it equal to 0. So take this group, set it equal to 0. Take this group, set it equal to 0. X equals negative 4. X equals positive 3. So there's your zeros. Negative 1, negative 4, positive 3. So if you were to graph this graph, which we're going to do that later before the chapter's over, if you were to graph this, you would have an x-intercept at negative 1, an x-intercept at negative 4, and an x-intercept at positive 3. Okay? That's what these zeros are. They're x-intercepts. Okay, students, moving on to number 13. Same thing, here we go. Always try to factor first. You're going to see it's not factorable, okay? You're going to pull out an x squared. We have a quadnomial, so remember we pull out what's common in the first two. Pull out what's common in the second two. And you need to hope that your parentheses match. Pull out your x squared. You're left with x negative 8. Here there's nothing common but a 1, and it's a negative 1. So you're left with 23x negative 30. These two parentheses are not even close to matching, so we're not going to be able to factor this, okay? So if we're not going to be able to factor, we're going to have to list out the possible rational zeros and start testing each one, okay? It's going to be a pain, but that's what you have to do. So here we go. My lead coefficient is 1. My constant term is 30. The factors of 1 would be 1 times 1, or just 1. The factors of 30 would be 1 times 30. 2 times 15, 3 times 10, 5 times 6. There we go. So put 1 over 1, you get 1. Put 30 over 1, you get 30. 2 over 1 is 2, etc. So your list would be positive negative 1, positive negative zeros, okay? So here we go. We're going to use synthetic division on each of these until we find a zero. Hopefully after we find one, what's left over can be factored. Remember, on the last problem after we found 1, 0, what was left over was this, and we could factor it and we were finished, okay? Hopefully that will happen. Let's see what happens. So students, here we go. First of all, let's get our synthetic division set up, okay? We have a coefficient. Our coefficient here is 1. We're not missing any terms. 3, 2, 1, constant term. So my next coefficient is -8, then -23, then +30. Now, let's make sure we have the right amount of numbers. We have 4 numbers here. My degree is 3. Add 1 to that in your head, you get 4. We should have 4 numbers here, and we do. Now I'm going to start with my smallest number, then go up to 2, then 3, then 5, then 6, and then 15, 10, 15, then 30. So my smallest number is 1. I'm going to start with 1 first. I'm going to try a +1. Bring down your 1. 1 times 1, combine. 1 times -7, combine. 1 times -30, -30, combine. Well, I got lucky, didn't I, guys? That doesn't happen very often, okay? So 1 is one of your zeros. 1 gave you out a 0. So I'm going to come up here and put zeros equal. My zeros so far are 1. Now, my degree is a 3rd degree, so I go 1 less than that. I'm left over with a 2nd degree. So my function now is x squared, -7x, -30. So maybe I can factor that. If I can't factor this, then I have to use synthetic division on this and test some more zeros, okay? Right, here we go. Now, I have a trinomial lead coefficient of 1, so what two numbers when multiplied together give me -30? When combined or added together give me -7. It's going to be -10, +3. When you multiply those, you get a -30. When you combine those, you get a -10. So the factorization is x -10, x +3. Okay? Now, take each group and set each group equal to 0. Bring your -10 over and make it positive. Bring your 3 over and make it negative. So there's the rest of your zeros. 10 and -3. How do I know I'm finished? Because there's nothing left to break down anymore. You broke this down. There's nothing left. There are your zeros. So if you were to graph this, you would have an x-intercept at 1, an x-intercept at 10, and an x-intercept at -3. Okay, remember what we learned in the past about left-hand characteristics, right-hand characteristics. This is a positive lead coefficient with an odd degree, so it would go down to the left and up to the right. So we know the graph's going to do something like this. It would hit here, come down, come up, like that. I'm just getting you guys ready for the graphing part we're going to do before this chapter's over, okay? Alright, let's check our answers, make sure we're correct, and we are correct. Number 15. Okay, let's find the zeros of this function. First of all, you always want to try to factor if at all possible. So we have a quadnomial. Pull out what's common in the first 2 terms, and you're left over with this. Pull out what's common in the second 2 terms. That'd be a +2, and you're left with this. The 2 parentheses do not match, so we're not going to be able to factor it like we've been doing. So we're going to have to list out the possible rational zeros and test them until we find a 0. Now, my lead coefficient is 1. My constant term is 40. The factors of 1 would be 1 times 1. And of course I don't want doubles, so it's just a 1. Factors of 40, 1 times 40, 2 times 20, 4 times 10, 5 times 8. And that's it. I know that because if I keep going up, 5, 6, 7, 8, then I start to repeat. 8 times 5, 10 times 4. So I'm finished. So 1 goes over 1, that's 1. 40 goes over 1, that's 40. 2 goes over 1, that's 2, etc. So I'll have positive negative 1, positive negative 40, positive negative 2, positive negative 20, positive negative 4, plus minus 10, plus minus 5, plus minus 8. Alright? So here's my list of possible rational zeros. So students, my new polynomial function is x squared, negative 9x, positive 20. Okay, so now I'm going to break all these down here. I'm going to get rid of this. And actually, I'm going to see if this is factorable. By the way, if it wasn't factorable, if you could not factor this, okay? If you couldn't factor this, then you'd have to start testing numbers again. By the way, you'd have to try negative 2 again. We know positive, we know these numbers don't work. Once a number doesn't work on this, it will also not work on this. Okay? So the positive 2 doesn't work, but you have to try the negative 2 again because sometimes there's repeats. But the good news is we can factor this. So let's factor it, okay? Here we go. It's a trinomial with a leading coefficient of 1. So what two numbers multiplied together give you 20? When add together give you negative 9. Well, if you multiply these two numbers, you get a positive 20. If you combine them, you get a negative 9. So the factorization would be x, negative 5, x, negative 4. Now take each group and set each group equal to 0. X minus 5 equals 0, so x equals 5. X negative 4 equals 0, so x equals 4. So your zeros would be negative 2, 4, 5. There are your zeros. You're done because there's nothing left to break down over here. Okay? And there we go. Oh, let's try number 17. Okay, step 1, we always try to factor first. So pull out what's common. In the first two terms, you can plot a 2 and an x squared. So you're left with x plus 2. Okay? Multiply that back through, you'll get what you started with right up here. Now pull out what's common here. It's going to be a 2 is common, but there's a negative sign here. So plot a negative sign. And you're left with x plus 2. Look at that, finally. Huh? Finally something nice here. So my parentheses do match. So I write my matching parentheses once. And I'm left over with 2x squared. Negative 2. Now I can take each of these and set them equal to 0 and solve. And then 2x squared minus 2 equals 0. Bring your negative 2 over and make it positive. Now divide both sides by 2. X squared equals 1. Divide both sides by 2 like this. 2's cancel, leaving you with 1. Take the square root of both sides. The square root of 1 is positive negative 1. We did it. There's nothing left to break down. So there's your zeros. Negative 2 and positive negative 1. Negative 2 and positive negative 1. Now that was nice. Whenever everything factors down nicely, makes the problem a lot easier. Number 19. Alright, here we go. This one's not going to factor down. In fact, just trust me, I'm going to save you time on this. If I try to factor this, I would not get matching parentheses. I would get x negative 5, and over here I would get negative 2. Be 7x negative 4, I believe. Something like that, but it would not, your parentheses would not match. So we're not going to be able to factor this, unfortunately. So we're going to have to list out the possible rational zeros. So here we go. My leading coefficient is 2. My constant term is 8. The factors of 2 would be 1 and 2. The factors of 8 would be 1 times 8 and 2 times 4. Put 1 over 1, 1 over 2. Done with 1. Put 8 over 1 and 8 over 2. Done with 8. Put 2 over 1, that's 2. Put 2 over 2, 2 over 2 is 1, we have 1 already. 4 over 1 is 4, we have a 4 already. 4 over 2 is 2, we have a 2 already. So I'm finished. So these are my this is my list of possible rational zeros. coefficient set up. I'm not missing any terms, a 3, a 2, a 1, and a constant term. So my coefficients are 2, negative 5, negative 14, 8. I have a degree of 3. Add 1 to that, I should have 4 numbers, and I do. Now, I've told you I like to start with my smallest numbers and work my way to my largest numbers. However, I always say fractions for last because fractions are a pain to put over here and then multiply and combine. So I start with my smallest numbers, not counting my fractions. My fractions will be the last thing that I do. Okay? Alright, here we go. So, let's start off with my positive 1 here. Bring down my 2. 1 times 2. Combine. 1 times 3. Combine. No way, you can see right away it's not going to work, okay? We're not going to get a 0. So let's try negative 1. Here we go. Negative 1 times 2. Negative 2. Combine. Negative 7. Negative 1 times negative 7. 7 combine. Negative 7. Multiply. You get 7. Not going to work. Alright, so next we're going to have to go with positive negative 2. Alright, let's try positive 2. 2 times 2. Combine. 2 times negative 1. Combine. 2 times negative 16, negative 32. No way. We're not going to get a 0 at all. So now let's try a negative 2. Alright. Bring down your 2. Negative 2 times 2. Combine. Negative 2 times negative 9, positive 18. Combine. Negative 2 times 4. Look at that. Negative 8. 0. So we're good. We're doing really well, okay? So we found one of our zeros. I'm going to come up here at negative 2. Gave me out a 0. So one of my zeros would be negative 2. Now I did have a third degree. So now I have a second degree. Okay? So let's write that down. 2x squared. Negative 9x. Positive 4. Now maybe I can factor this. Maybe I can't. Okay, let's see. Pull my list down here. We can pull it back up again. Later we can go on this if we need to. We can pull it up here later. And then pull it back out again if we need to, okay? We might need it. We might not. Did not want to do that. Alright, here we go. Okay, let's see if we can factor this. I have a trinomial with a lead coefficient of 2. I wish this was a 1 right here. It would make it easier, but it's not. So do you remember what to do? You take this number here times this number here and write it over here. Positive 2 times positive 4. Positive 8. So what two numbers when multiplied together give me 8? When add together give me negative 9. How about these two numbers? If I multiply them, I get positive 8. If I combine them, I get a negative 9. So I bring down my first term, bring down my last term, and right in the middle I put negative 8x and negative 1x. And now I have a quadnomial. Let's pull out what's common in the first two. And I'm left over with x negative 4. Pull out what's common here. Well, there's nothing common but a 1, so pull out a 1. But whenever this term is negative, you want to pull out a negative sign too. So we're left with x minus 4. Alright, so do my parentheses match? Of course they do. So x negative 4, and I'm left over with 2x minus 1. There we go, I did it. I took this and factored it down to this. And now all I have to do is take each group and set each group equal to 0 and solve. Bring your 4 over and make it positive. Here, bring your 1 over and make it positive, then divide by 2. And 1 divided by 2 is 1/2. So my zeros are negative 2, positive 4, positive 1/2, negative 2, positive 4, positive 1/2. Okay, there it is. Alright, moving on to the next section. We're going to find all the real zeros, rational or irrational, it doesn't matter. Okay, rational or irrational does not matter. Okay, students, here we go. First of all, you know what to do. We're going to pull out what's common and hope that we can factor it, okay? We have a quadnomial, so pull out what's common in the first two and you're left with this. parentheses match? Yes, they do. My other parentheses would be x squared negative 2. There we go. Look at that. I did it. This entire expression here factored down to this right here. So now take each group, set each group equal to 0, and solve. There we go. Bring the 1 over and make it negative. Here, bring the 2 over and make it a positive 2. Now take the square root of both sides, and we're just going to leave it in radical form. The square root of 2 is the square root of 2. Don't forget your plus minus in front of the radical. We know we're done because there's nothing else left to break down, so my zeros are negative 1, comma, positive negative square root of 2. Now, listen to me. In the last problems we did, 19, 17, 15, 13, 12, or 11, those problems there, they wanted only rational answers. So if I was doing a problem like I was in the last section, I would not include this answer. I would include this answer only, because that's rational and this is irrational. However, the directions for this section say to find all real zeros. Doesn't matter if they're rational or irrational, find them all. So I have 1 rational zero, 2 irrational zeros right here, for a total of 3 zeros. And that's my answer. Okay? Alright, moving on to number 23. Alright, maybe we'll get lucky on this one. Maybe it'll factor. We'll see. Okay, we have a quadnomial, so pull out what's common in the first 2. Pull out what's common in the second 2. That's a 9. Because this is negative, we got to pull out a negative. And we're left with, look at that, x plus 2. So my parentheses do match. In my other parentheses, x squared plus 9, or x squared minus 9, excuse me. Now take each parentheses and set each parentheses equal to 0. Here, bring the 2 over and make it negative. X equals negative 2. That's 1, 0. Here, bring the 9 over and make it a positive 9. And now take the square root of both sides. The square root of x squared is x, and the square root of 9 is, don't forget, your positive negative 3 plus minus. I'm done, guys. There's nothing else I can break down. Negative 2, positive negative 3 are my zeros. In other words, if I were to graph this thing, I would have an x-intercept at negative 2, negative 3, and positive 3. And there's my x-intercepts, okay? Alright, moving on. 24. Okay, let's see here. Nothing. What can I pull? This is a quadnomial. I always try to factor first. So I have a quadnomial here. So let's pull out what's common in the first 2 terms. X squared I'm left over with 2x minus 1. Pull out what's common here. It's going to be a 16, but because there's a negative sign here, pull out a negative sign. And you're left with, look at that, 2x negative 1. Awesome. So write your matching parentheses once. And you're left over with x squared negative 16. So we've taken this expression and factored all the way down to this. Now take each group and set each group equal to 0. Bring your 1 over and make it positive. 2x equals 1. Now divide both sides by 2. And there's 1, 0, 1 half. Over here, bring the 16 over and make it a positive 16. Take the square root of both sides, and you get positive negative 4. So if I was graphing this, I would have an x-intercept at negative 4, an x-intercept at positive 4, and also an x-intercept at 1 half. So right here, there we go. Okay, guys. Alright, so there's my zeros. 1 half, positive negative 4. 1 half, positive negative 4. Okay. Alright, 26 looks good because 27 looks good because we're finally doing a problem higher than a 3rd degree. It's a 4th degree. And the same thing in 29. It's a 5th degree. That'll be good for us, okay? So here we go. Let's go ahead and try number 27. Alright, first of all, always try to factor first. However, this is a 5-term polynomial. We've never learned how to factor those, so we're not going to be able to factor it, okay? So what we're going to do rational zeros and start checking them, unfortunately, because I cannot factor, so my lead coefficient is 1. My constant term is negative 24. Factors of 1 would be 1. Factors of 24 would be 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then it starts to repeat 6 times 4. So that's it. Now you're putting 1 over 1, 24 over 1, 2 over 1, etc. So my possible rational zeros will be positive negative 1 plus minus 24 plus minus 2 plus minus 12 plus minus 3 positive negative 8 positive negative 4 and positive negative 6. There we go. If any rational zeros exist in this function, they will be in this list somewhere. Okay, somewhere they will be there. Alright, moving on. Let's see what we got here. Let's factor. Let's start not factor. Let's set up our synthetic division here. And my coefficient, I'm not missing any terms. I have a 4, 3, 2, 1 constant term. So my coefficients are 1, 9, 5, negative 27, negative 24. Now my degree is 4. Add 1 to that, you get 5. I should have 5 numbers, and I do. Let's start with my small numbers first. Let's start with the positive 1. Bring down your first number. 1 times 1, combine. 1 times 10, combine. 1 times 15, combine. 1 times negative 12, not going to work. We're not going to get a 0, so we're going on. Let's try negative 1 now, alright? Negative 1 times 1, combine. Negative 1 times 8, combine. Negative 3. Negative 1 times negative 3, 3, combine. Negative 24. Negative 1 times negative 24, positive 24. Booyah, 0. So negative 1 gave me out a 0, alright? So negative 1 is one of my zeros. I'll put it up here. Now, I did have a 4th degree. Now I've broken it down to a 3rd degree. So here we go. I have x cubed, positive 8x squared, negative 3x, negative 24. There we go. Okay. So, now, we might be able to factor this. If we can't, we're going to have to go back through and test my zeros. Now, positive 1 doesn't work, so if positive 1 did not work with this function, it will also not work with this function. However, sometimes you have repeats, so you would have to test negative 1 again in this function, but maybe it's factorable. Let's see if it is. We have a quadnomial. Pull out what's common in the first two, like I've taught you to do, and you're left with this. Here you have a 3 that's common, pull out a 3 because it's a negative sign here, pull out a negative 3, and you're left with this. So thankfully we're good, okay? So, my factorization would be x positive 8, x squared negative 3. There we go, okay? So take this parentheses here, set it equal to 0 and solve. Take this group here, set it equal to 0 and solve. Bring the 8 over and make it negative. So there's 1, 0. Bring the 3 over and make it a positive 3. Now take the square root of both sides. The square root of x squared is x, and the square root of 3, we're going to leave it in radical form, is this right here. So my zeros, I have negative 1 for a 0, negative 8 for a 0, and positive negative square root of 3. And that's good. That's it. There's nothing left to break down. Now I'm looking in the book. I do have the answer key for this one. And I'm looking, and it is correct. We have it right. Okay. So one more problem. We're finished. I know this has been a pretty long assignment, but one more problem, and we'll go from there. Okay. All right, number 29. All right. First of all, you always want to try to factor. factor a 6-term polynomial function, okay? So, I'm going to have to list out possible rational zeros and go that route, okay? So here we go. My lead coefficient is 1. My constant term is 15. Factors for 1 would be 1 times 1. Factors for 15 would be 1, 15, 3, 5. Okay? So, 1 over 1, 15 over 1, 3 over 1, 5 over 1. You're going to end up with positive negative 1, positive negative 15, plus minus 3, plus minus 5. There we go. There's my list of possible rational zeros. If this function has any rational zeros, they will be in this list right here. They have to be. Okay? Alright, moving on. Now, first of all, we're going to have to set up our synthetic division here, okay? So there we go. I have no missing numbers. I've got a 5, 4, 3, 2, 1, and a constant term. So I'm not missing any numbers. So 1, write my coefficients down here, like I've taught you to do with your synthetic division. There we go. Now, I have a degree of 5. Add 1, that's 6. There should be 6 numbers, and there are. I'm going to start with my smallest number first, which is 1. Bring down my first number. 1 times 1. Combine. 1 times 6. Combine. 1 times 8. Combine. 1 times negative 14. Combine. We're not going to get the 0. You can see that already. It's not going to work, so that's not going to work. So now let's try a negative 1. Let's cross off our positive sign. It's no good. Alright, negative 1 times 1, negative 1. Combine. 4. Negative 1 times 4, negative 4. Combine. Negative 2. Negative 1 times negative 2, 2. Combine. Negative 20. Negative 1 times negative 20, positive 20. Combine. Negative 15. Negative 1 times negative 15, positive 15, 0. So we did it. So negative 1 gave me out a 0. So there's one of my zeros, negative 1. Put it right here. Now we did have a 5th degree. Now we've broken it down to a 4th degree. Alright, 4th degree. 3, 2, x constant term. So now I have x to the 4th, positive 4x cubed, negative 2x squared, negative 20x, negative 15. Got it? Now, we're not going to be able to factor that. We know that for sure because it's a 5-term polynomial. And we've never learned how to factor a 5-term polynomial. Mr. Error, do we have to list out the possible rational zeros? Absolutely not. No. Okay? You do not. These numbers here, if they work here, they'll work in this one. Now, we already know positive 1 doesn't work. If positive 1 did not work in this function here, it's not going to work in this function here. However, if negative 1 worked here, it might work here. Can we have repeats, Mr. Error? Yes, you can. You can definitely have repeats. So we're going to start off with negative 1 for my synthetic division. So set up your synthetic division here. We're going to use these coefficients here. We're not missing any terms. 4, 3, 2, 1, constant term. So I'm going to put a coefficient of 1, coefficient of 4, coefficient of negative 2, coefficient of negative 20, coefficient of negative 50, or a constant term of negative 15. My degree is 4. In your head, add 1 to that, you get 5. I should have 5 numbers here, and I do. Now, we know negative 1 works, but in order to break this down into a 3rd degree, negative 1 might work again. Let's see if it does. Negative 1 times 1, combine. Negative 1 times 3, combine. Negative 1 times negative 5, combine. Negative 1 times negative 15, positive 15. Look at that, it did work. I didn't think it was going to. I kind of paused right there because I didn't think it was going to. I was surprised that it actually worked, but it did. So negative 1 gave me out 0. Do I need to put negative 1 up here again? Of course not, no. But do you see what you did? You just broke this down from a 4th degree. Now it's into a what degree? A 3rd degree. So now my new function is x cubed plus 3x squared minus 5x minus 15. Now maybe we can factor that. I'm going to go ahead and tell you now that we can factor that. I can see already we're going to be able to factor that. So that's great news. So we have taken, look at this guys, we have taken this 5th degree polynomial function right here. And now we've broken it all the way down to a 3rd degree polynomial function. Okay, this is a quadnomial. Pull out what's common in the first two and you're left with this. Pull out what's common here. It'd be a 5, but make it a negative 5. There's a negative sign here. And you're left with x plus 3. Write your matching parentheses once. Your other parentheses would be x squared negative 5. Take your first parentheses, set it equal to 0 and solve. Take your next parentheses, set it equal to 0 and solve. Bring your 3 over and make it negative. X equals negative 3. Here, bring your 5 over and make it a positive 5. Take the square root of both sides. The square root of x squared is x, and the square root of 5 is positive negative square root of 5. So your zeros are negative 1, negative 3, and positive negative square root of 5. And we did it. Wow, that was a long problem. But it's good that you guys know how to do these, okay? Alright guys, that's it. I hope this homework help video has been help to you guys. If you have any questions at all, please don't hesitate to call or email.